All right, so in this video, we're going to talk through some of these acid-base reactions. We're going to look at some practice problems here. And this first one is nitric acid and lithium hydroxide. So I'm going to write both the molecular and then the net ionic versions of these reactions. And typically on a test, you would only be asked to write the net ionic version. I'm going to practice writing out both here. So this is a double displacement style reaction. So like the hydrogen and lithium switch places. Notice that when that happens, the hydrogen combines with the hydroxide, forming liquid water. And then the other two ions combine to form an ionic compound known as salt. So salt is just a general category of these ionic compounds that are formed during these acid-base neutralization reactions. And we know based on solubility rules that it's a nitrate compound, it's soluble. Okay, and then if we think about the net ionic equation, remember that strong acids break apart into ions. Soluble ionic compounds break apart. Here's another soluble ionic compound. And then water does not ionize. It mainly stays stuck together. So I'm going to look for spectators. So lithium, nitrate. So what's left behind is hydrogen and hydroxide forms water. So that's my net ionic equation here. And in order to write this net ionic equation carefully, we have to know what our strong acids are. So that list of 6 strong acids is really important to know. So the ones you'll most commonly run into are these ones, H2SO4, and I think the other one like HClO4 we don't see as often, but those are these strong acids you need to be aware of. Okay, let's look at the next one. So here's another acid-base combo. Notice how this acid is not one of these 6 strong acids we just mentioned. So it is a weak acid. And what that means is, let's start to write this out. So we make sodium acetate. That is my salt. And then I'm going to make liquid water. And the implications of it not being a strong acid is that it's not going to completely ionize. So when we go through to write the net ionic equation here, my ionic compound is going to ionize. But this is a weak acid, so it is not going to ionize. But then over here, sodium acetate, that's an ionic compound, so that is going to ionize. And then water is a liquid, so it will not ionize. So just keep in mind when you're ionizing things, you're ionizing strong acids and the soluble ionics. Okay, those are the 2 things you want to ionize. Boom. So notice in this case, we only have one spectator. It's the sodium ion. So what we're left with is hydroxide and HC2H3O2 make the acetate ion and liquid water. Okay. Here's another one here. We've got an ionic compound. And this one, it looks like this one I might actually ionize first before I try and figure out the product. So this is which you always have an option of doing that one. So I'm going to recognize this as like, hey, this looks like a weak acid. Well, let me say this. First, I'm going to recognize and say this is an ionic compound. So NH4Cl, it's an ionic compound. So it's break apart to form ammonium and chloride. And then this is a strong base. Okay, so I say, well, who's going to react? I want to recognize like what type of reaction this is. This is a reaction between a weak acid and a strong base. So the sodium and chloride are not really going to do anything. So let me rewrite this over here to the side. Ammonium, which is my weak acid, is going to react with hydroxide, the strong base, to form the conjugate base, ammonia, and water. So if we were to kind of go over a pattern that we're seeing so far, is one of the patterns we should notice is whenever you have a strong acid plus a strong base, the reaction is always going to be hydrogen plus hydroxide makes water. That's the net ionic equation, no matter what your strong acid is. If it's nitric or sulfuric or hydrochloric, that's going to be the net ionic equation. When you're looking at a weak acid plus a strong base, the general format is going to look like this. You're going to have your acid and hydroxide, and it's going to leave behind the conjugate base and water. So that's what B and C fit into that general category. Now let's take a look at D. D is the other option we haven't mentioned yet, which is what if you have a weak base and a strong acid. In this example, the base is going to take the hydrogen from the strong acid and it is going to form the conjugate acid. So ammonia is a weak base. HCl is a strong acid, so it's going to totally ionize. And then the NH3 being a base, it's a hydrogen taker, so it's going to take the hydrogen and form NH4. And then what's the chlorine doing? Nothing. Okay, the chlorine's not really doing anything, so we'll go back afterwards and eliminate it. It's a spectator. So here's your overall net ionic equation there. And then here's another one. We got HF. We got to be aware of our list of strong acids. HF is not one of the strong. That means it is weak. So you've got a weak acid, and you've got a whoops, what's going on here with my pen? Okay. You've got a weak acid, and you've got a strong base here. And so I know it's going to follow this kind of pattern right here. So my pattern is that the weak acid, the strong base is going to take a hydrogen from the weak acid, forming water. And then what's left behind is the fluoride ion. And then the potassium's left behind as well. It's a spectator. It's not really doing anything. So we're going to go back and we're going to erase the potassium. And here's our net ionic equation. Weak acid plus strong base makes water, and the conjugate base of this acid there. So that's this kind of general pattern. All right, here's another one. This looks like a weak base and a strong acid. So this one's going to follow this pattern right here. So remember, with weak bases, the two main categories of things that can be weak bases are amines, so things containing nitrogen, like ammonia. It's a common example. And then also anions. Anions are good possible weak bases because they're negative, so they can be good hydrogen takers. All right, so this is, again, is following this pattern right here. And then let's look at one more, propanoic acid. It's not one of our 6 strong acids, so therefore it must be a weak acid. CH3, CH2, COOH. It's titrated with sodium hydroxide, so you got a strong base here, and it's going to form water plus. You might be wondering, how should I write this compound? Typically rewrite it this way. The key thing is this should lose a hydrogen, and then it should have a negative charge. And if you're wondering why it's written this way, because you might look at this and say, gosh, that looks like a base almost. It looks like there's a hydroxide there. That COOH is a way to indicate that you have something called a carboxylic acid, which looks like this. So that's something we kind of recognize in organic chemistry, carboxylic acid. And what happens here is this hydrogen will actually break off, and that's what makes it acidic, is this hydrogen right here. So yeah, hope that helps.